Have you ever noticed how some places on Earth feel shaped by forces so extreme they seem unreal? In this episode of Unearthed Secrets, we explore explosive Arctic craters, color-shifting volcanic lakes, rivers that bloom with color, deserts carved by time, underground rivers of fire, and stone forests left by vanished seas. Before we begin, like and subscribe, and tell us in the comments where you're watching from and what time it is for you right now. The holes that appeared overnight. On the frozen tundra of northern Siberia, where the ground is supposed to remain solid for thousands of years, enormous holes have appeared without warning. Perfectly round, steep-walled, and plunging deep into the earth, these craters seem to emerge overnight. There were no impact scars, no lava flows, no warning signs visible from the surface. When the first images surfaced in 2014, speculation spread rapidly. Meteor strikes, secret weapons, even fictional explanations. But the truth, while less dramatic on the surface, is far more unsettling. These are the Yamal Craters, evidence that the frozen ground beneath the Arctic is no longer stable. The Yamal Peninsula lies well above the Arctic Circle in northwestern Siberia. The name Yamal comes from the Nenets language and means the end of the land. It's an apt description. This is a region defined by vast tundra, extreme cold, and permafrost, ground that has remained frozen continuously for tens of thousands of years. Until recently, permafrost was considered permanent. The sudden appearance of the Yamal craters challenged that assumption. The first crater was discovered in July 2014 by a helicopter crew flying over the tundra. From the air, it looked like a dark circular void punched straight into the ground. The crater was roughly 40 meters wide and more than 30 meters deep, with nearly vertical walls and no debris piled around the rim. That absence of debris was the first clue. If the hole had been caused by an impact from space, material would have been thrown outward. If it had been caused by collapse alone, the edges would have slumped inward unevenly. Instead, the crater looked as if something had burst upward from below, ejecting material into the air and leaving behind a clean, cylindrical cavity. Within months, more craters were found. Some were smaller. Some partially collapsed. Others had already begun filling with water, transforming into perfectly round lakes. Together, they revealed a pattern, not a single anomaly, but a regional phenomenon. Scientists began investigating immediately. The key to understanding the Yamal craters lies beneath the tundra, locked inside permafrost. Permafrost is not just frozen soil. It is a complex mixture of earth, ice, organic material, and trapped gases. One of those gases is methane, a potent greenhouse gas produced by the decomposition of organic matter. For thousands of years, methane in the Arctic remained safely trapped. Cold temperatures kept permafrost solid, sealing gas beneath the layers of frozen ground. But as Arctic temperatures rise, that seal is weakening. In Yamal, warming temperatures began to thaw the upper layers of permafrost. This thawing did not release methane gently. Instead, it allowed pressure to build. Beneath the surface, methane gas accumulated in pockets. Ice-rich permafrost acted like a cap, preventing the gas from escaping. As pressure increased, the ground above began to bulge, subtly at first, then more dramatically. Eventually, the pressure became too great. The result was a gas explosion. When the permafrost cap failed, methane burst upward violently, ejecting soil, ice, and debris into the air. What remained was a deep crater with frozen walls and little surrounding rubble. Exactly what researchers observed. This process is now known as a cryogenic gas eruption. Unlike volcanic explosions, these eruptions involve no magma. Unlike sinkholes, they are not slow collapses. They are sudden, energetic releases driven by gas pressure beneath frozen ground. Measurements taken inside the craters confirmed this explanation. High concentrations of methane were detected in and around the cavities. Isotopic analysis indicated that the gas originated from deep within the permafrost, not from surface sources. Some craters showed evidence of fire or scorching, suggesting that methane may have ignited briefly upon release. Others did not. This variability suggests that the explosions differ in strength and behavior depending on local conditions, ice content, gas volume, soil composition, and temperature. The Yamal craters are not isolated curiosities. They are part of a broader pattern unfolding across the Arctic. As global temperatures rise, Arctic regions are warming at more than twice the global average. This phenomenon, known as Arctic amplification, accelerates permafrost thaw. When permafrost thaws, it does more than create craters. It destabilizes infrastructure, it releases greenhouse gases, it alters ecosystems. The Yamal Peninsula is particularly vulnerable because it contains vast natural gas reserves. Beneath the tundra lies some of the largest gas fields on Earth, connected to pipelines that supply energy to much of Russia and Europe. While the Yamal craters are not directly linked to industrial drilling, they highlight the sensitivity of the region's geology. Changes in ground stability pose risks not only to the natural environment, but to roads, pipelines, and settlements. The Nenets people, who have lived on the Yamal Peninsula for centuries, are already seeing changes. Their traditional reindeer migration routes are disrupted by thawing ground, collapsing riverbanks, and newly formed lakes. What was once predictable terrain is becoming unstable. From a scientific perspective, the craters are invaluable and alarming. They provide direct evidence of methane behavior in thawing permafrost. Methane is far more effective at trapping heat than carbon dioxide over short timescales. Large sudden releases can accelerate warming, creating feedback loops. Warming thaws permafrost, thaw releases methane, methane causes more warming. The Yamal craters may represent one extreme expression of this cycle. Not all methane escapes explosively, much of it seeps slowly into the atmosphere, but explosive releases are harder to predict, harder to measure, and potentially more dangerous. Researchers now monitor the region using satellites, drones, and field expeditions. They look for surface bulges, early warning signs of gas buildup. They track temperature changes, ice content, and gas emissions. Some scientists believe many more craters may form in the future. Others caution that explosions require very specific conditions and may remain relatively rare. What is clear is that the Arctic is no longer static. The craters themselves are temporary features. Over time, their walls collapse. Snow and rain collect at the bottom. Within a few years, most become lakes indistinguishable from thousands of others dotting the tundra. Only satellite imagery and historical records reveal their violent origins. This makes the phenomenon difficult to track. A crater forms, it erodes, it disappears, but the process that created it continues. The Yamal craters challenge long-held assumptions about frozen ground. They show that permafrost is not merely melting, it is reacting. They also challenge perceptions of geological timescales. These are not changes unfolding over millennia. They are changes occurring within years, sometimes within a single season. Standing at the edge of a Yamal crater, researchers describe an unsettling silence. The walls are icy and layered, revealing frozen soil tens of thousands of years old. The bottom may be dark, wet, and cold. There's no sense of gradual erosion, only abrupt absence. Something was there, then it was not. The tundra looks unchanged from a distance. From above, it still appears vast, flat, and empty. But beneath the surface, pressure is building in places unseen. The Yamal craters are not signs of the Earth breaking apart violently. They are signs of it loosening. Frozen systems that once held firm are beginning to fail. Not everywhere, not all at once, but enough to matter. In Siberia, where the ground was once trusted to remain solid forever, the land has started to open, quietly, suddenly, without warning. The holes are not messages. They are symptoms, evidence that the Arctic is entering a new phase, one where even the coldest ground on Earth can no longer be taken for granted. At the end of the land, the Earth is changing from below. The lakes that change their color. High on the island of Flores in eastern Indonesia, there's a volcano whose summit does not glow with lava or echo with explosions. Instead, it holds 3 quiet lakes, each sitting in its own crater, each changing color without warning. At times they are turquoise, black, rust red, jade green, or pale blue. Sometimes 2 lakes shift together. Sometimes only one changes, while the others remain still. There's no schedule, no pattern that can be relied upon. This is Mount Kelimutu, a volcano where chemistry, heat, and gas quietly rewrite the landscape again and again. The Mount Kelimutu rises to about 1,639 meters above sea level in central Flores, part of Indonesia's vast volcanic arc. Unlike many volcanoes in the region, Kelimutu is not famous for violent eruptions. Its power is expressed in subtle instability, through water, gas, and mineral reactions occurring just beneath the surface. At the summit of Mount Kelimutu lie 3 crater lakes, separated by narrow ridges of rock. Though they sit only meters apart, each lake behaves differently, with its own chemistry, temperature, and history. Their modern names reflect both science and belief. Tiwatambupu is often called the Lake of Old People. Tiwu Nua Murikufai is known as the Lake of Young Men and Maidens. Tiwu Atapolo is referred to as the Enchanted or Bewitched Lake. These names come from local traditions that long predate scientific explanation. Geologically, the lakes exist because Kelimutu is a stratovolcano formed by subduction. Here, the Australian plate is sliding beneath the Eurasian plate, melting rock deep below and feeding magma upward. Though Kelimutu's last major eruption occurred in the early 20th century, heat continues to rise beneath the summit. Rainwater collects in collapsed craters, forming lakes. What makes Kelimutu unique is what happens after the water settles. Volcanic gases, particularly sulfur dioxide, carbon dioxide, and hydrogen sulfide, rise from below and dissolve into the lake water. These gases react with dissolved metals such as iron and manganese. Changes in gas input, temperature, or water level alter the chemical balance. When chemistry changes, color follows. Iron-rich water can appear red, brown, or yellow when oxidized. Reduced iron can turn the water blue or green. Sulfur compounds darken the lake toward black or gray. Algal growth, influenced by temperature and acidity, adds further variation. Because each lake has its own plumbing, its own gas vents and underground connections, they change independently. This independence is what makes the scene so unsettling. At times, all three lakes display dramatically different colors simultaneously. One may glow turquoise, another may be dark and opaque, the third may be rust red, as if stained with blood. Days or weeks later, the colors may shift again. There's no single trigger. Rainfall can dilute acidity. Earthquakes can open or close gas pathways. Temperature changes alter chemical reactions. Even wind affects surface oxidation. Mount Kelimutu is sensitive to small changes, and those small changes are visible. Historically, Kelimutu has not been entirely calm. Records describe eruptions in the late 19th and early 20th centuries, including ash emissions and gas releases. These events reshaped the summit and altered lake chemistry dramatically. In 1968, a sudden gas release killed several people in nearby villages, likely due to carbon dioxide escaping from underground systems. This tragedy highlighted that even a quiet volcano can be deadly. Since then, Kelimutu has been carefully monitored. Scientists regularly sample lake water, measure temperature, acidity, and gas output, and track color changes over time. Each shift provides clues about what is happening beneath the volcano. The lakes act like windows into the system. A sudden color change may indicate increased gas flow. A drop in water level may signal rising heat. A temperature spike can precede minor eruptions or gas releases. For volcanologists, Kelimutu is a natural laboratory. For local communities, it is something else entirely. The people of Flores have long believed that the lakes are the final resting places of souls. According to tradition, the spirits of the dead travel to Kelimutu after death, settling into the lake that matches their life and character. Elders go to Tiwu Atambupu. The young go to Tiwu Nua Murikufai. Those who live troubled or harmful lives go to Tiwu Atapolo. Color changes are interpreted as signs, messages from the spirit world reflecting balance, unrest, or transition. Ceremonies are sometimes held when dramatic shifts occur, acknowledging the volcano's influence over life and death. These beliefs coexist with scientific understanding rather than competing with it. The lakes are respected, not challenged. The summit environment is harsh. Winds are strong. Clouds move quickly. Temperatures fluctuate sharply. The crater rims are narrow and unstable, shaped by erosion and past collapses. Vegetation is sparse near the top, giving way to dense forest lower down. This forest is rich in biodiversity, part of Flores' complex ecosystem shaped by isolation and volcanic soil. From the summit, the lakes appear calm. There are no waves, no visible movement, but beneath the surface, water circulates slowly, heated unevenly from below. Gases rise silently. This contrast, stillness above, instability below, is what defines Mount Kelimutu. The colors themselves are not permanent records. Photography from the early 20th century shows entirely different hues than those seen today. In some years, the lakes appear similar in color. In others, they diverge sharply. Tiwu Atapolo, in particular, is the most volatile. It has shifted from red to black to green to blue multiple times within a single decade. Its chemistry is the most extreme, often highly acidic. Tiwu Ata Mbupu tends to be more stable, though it too changes slowly over time. Tiwu Nua Morikufai often displays the most vibrant blues and greens. The fact that three lakes behave so differently while sharing the same summit makes Kelimutu unique in the world. Other volcanoes have crater lakes. Some change color. None do so in unison and contrast like this. Climate change introduces new uncertainty. Changes in rainfall patterns could alter water levels and chemistry. Increased storms could mix lake layers more frequently. Drought could concentrate minerals further. While climate does not drive volcanic heat, it influences how that heat interacts with surface water. Mount Kelimutu's future is not fixed. It may erupt again. The lakes may drain. New craters may form. Or the volcano may remain quiet for centuries, expressing its activity only through shifting colors and gas emissions. For visitors, the experience is brief but powerful. Sunrise is the most dramatic time. As light reaches the summit, colors emerge gradually from darkness. Mist lifts. The lakes reveal themselves one by one. No visit is the same. Some days, clouds obscure everything. Some days, one lake dominates. On rare days, all three are vivid and distinct. There is no guarantee. This uncertainty is part of Kelimutu's identity. Mount Kelimutu does not announce its changes. It does not erupt loudly. It does not demand attention. It simply changes, quietly, persistently, without explanation. In eastern Indonesia, above forests and villages, three lakes continue to shift color as gases rise and chemistry rearranges itself beneath the ground. They are not illusions. They are not reflections. They are records of heat, pressure, and movement deep below a seemingly calm surface. Mount Kelimutu reminds us that not all volcanic activity is explosive. Some of it is slow, subtle, and visible only through color. A volcano that speaks in chemistry, a summit that never looks the same twice, a place where the earth reveals its instability without making a sound. The river that runs with color. In the heart of Colombia, far from major cities and industrial development, there's a river that does not behave like water should. Its bed glows red, yellow, green, blue, and black, as if paint has been poured directly into the current. The colors shift with sunlight, season, and depth, appearing vivid one moment and subdued the next. From above, the river looks unreal, like a ribbon of color woven through stone. This is Cano Cristales, often called the River of Five Colors, a place where biology, geology, and climate align so precisely that the landscape seems designed rather than formed. The Cano Cristales flows through the Serranía de la Macarena, an isolated mountain range in central Colombia that stands apart from both the Andes and the Amazon basin. This isolation is the key to everything Cano Cristales is, and everything it is not. The river's appearance is not caused by minerals, algae blooms, or pollution. It is not stained by odd sediment or chemicals. Its colors come from a single rare aquatic plant, Macarenia clavigera. This plant grows only in very specific conditions, and those conditions exist in very few places on Earth. Macarenia clavigera anchors itself to bare rock, in fast-moving, shallow water. It requires intense sunlight, clean water, and precise seasonal timing. When water levels are too high, the plant receives insufficient light and appears green or brown. When water levels are too low, it dries out and disappears entirely. But when conditions are just right, typically between July and November, the plant transforms. Its leaves turn bright red, pink, and magenta as pigments protect it from intense sunlight. These pigments, combined with the reflections from water, stone, sand, and sky, produce the full spectrum of colors seen in Cano Cristales. The river does not always look like this. For part of the year, Cano Cristales appears ordinary. During the dry season, the plants recede. During heavy rains, the river swells, muting colors beneath deeper water. Only during a narrow seasonal window does the river become what it is famous for. This timing makes Cano Cristales a phenomenon, not a constant. Geologically, the river flows across some of the oldest exposed rock in South America. The Serranía de la Macarena is composed largely of ancient quartzite and sandstone, dating back over 1 billion years. These rocks are incredibly hard and resistant to erosion. As a result, the river doesn't carve deep channels or carry much sediment. Instead, it flows over smooth rock slabs, creating shallow pools, cascades, and channels that expose the riverbed completely. This lack of sediment is essential. If the river carried mud or silt, light would scatter and plants would be buried. The water would turn opaque. The colors would disappear. Cano Cristales depends on geological stability and clarity. The water itself is remarkably pure. There are few nutrients in the river. Little organic matter enters it. Fish are scarce. Insects are limited. This low nutrient environment prevents algae from taking over, allowing Macarenia clavigera to dominate. In most rivers, such conditions would be considered lifeless. Here, they are perfect. The Serranía de la Macarena is often described as a biological crossroads. Species from the Andes, the Amazon, and the Orinoco Basin overlap here, creating extraordinary biodiversity in surrounding forests. But Cano Cristales itself is selective. Life in the river is minimal by design. This selectivity extends to humans as well. For decades, Cano Cristales was largely unknown to the outside world. The region was isolated by geography and conflict. Armed groups operated nearby, and access was restricted. This unintended protection preserved the river. Only in the early 21st century did tourism begin to develop under strict controls. Today, access to Cano Cristales is carefully regulated. Visitors are limited in number and season. Swimming is restricted to specific areas. Sunscreen, insect repellent, and chemical products are prohibited, as even small amounts could disrupt the river's fragile balance. There are no hotels along the river. No roads cross it. Infrastructure is minimal. This restraint is intentional. Cano Cristales does not tolerate disturbance. Even footprints can damage plants. Changes in water chemistry can alter growth. Increased sediment can suffocate the riverbed. Preservation here requires absence as much as presence. From a scientific perspective, Cano Cristales demonstrates how ecosystems can exist at the edge of possibility. The river's beauty is not the result of abundance, but of limitation. Few nutrients, few species, few variables allowed. Remove any one of these constraints, and the system collapses. Climate plays a decisive role. Rainfall patterns determine water depth and timing. Extended droughts could dry the riverbed too long. Prolonged heavy rains could keep water levels too high. Climate change introduces uncertainty into this delicate cycle. If seasonal rhythms shift, the colors may fade or vanish. This vulnerability makes Cano Cristales not just a wonder, but a warning. It shows how tightly beauty can be tied to balance. Culturally, the river has gained symbolic importance in Colombia's post-conflict identity. Once inaccessible due to violence, it is now presented as a symbol of recovery, conservation, and peace. Its protection reflects a broader effort to preserve natural heritage after decades of instability. Yet, the river itself remains indifferent to symbolism. It does not care why humans arrive. It responds only to light, water, and chemistry. When sunlight hits shallow pools, reds intensify. When clouds pass overhead, colors dull. When wind ripples the surface, reflections break and reform. The river is never static, even within a single day. From above, the patterns look deliberate, bands of color following rock contours. From within, the experience is subtler. Water is clear and cool. Stones are smooth. Color appears beneath the surface, not floating above it. It is not paint. It is structure. Cano Cristales challenges assumptions about what creates beauty in nature. It is not size, height, or force. It is precision. No towering mountains. No massive waterfalls. No violent events. Just alignment. The right rock, the right plant. The right water, the right season. Miss anyone, and the river becomes ordinary. Over geological time, Cano Cristales is fleeting. The rocks beneath it are ancient. The river itself may shift course. Plants may evolve or disappear. Climate may change enough to end the phenomenon entirely. What exists now is temporary, and that impermanence is part of its meaning. Cano Cristales is not a spectacle designed to endure forever. It is a moment repeated annually, as long as conditions allow. Each year it returns slightly different. Each year it risks not returning at all. Standing beside the River, the colors feel less like decoration and more like evidence. Proof that under the right circumstances, natural systems can create results that feel intentional, even miraculous, without intention at all. In central Colombia, where ancient rock meets clean water and fragile life, a river runs red, yellow, green, and blue. Not because it wants to be seen, but because everything else has stayed out of its way. Cano Cristales does not demand attention. It simply appears, briefly, brilliantly, then fades back into stone and water, waiting for the next season when balance allows color to return. The desert that remembers everything. In southern Jordan, where the land opens into vast silence and stone rises like frozen waves, there is a desert that feels less like an empty place and more like a memory carved into the earth. Towering sandstone mountains emerge abruptly from flat sand plains. Narrow canyons cut deep into red rock. Natural arches span open space with improbable balance. The air carries sound differently here, and time seems to slow. This is Wadi Rum, a desert shaped by water, wind, tectonics, and human passage across tens of thousands of years. The Wadi Rum lies near Jordan's southern border, east of the Red Sea and north of Saudi Arabia. Officially known as Wadi Rum Protected Area, it covers more than 700 square kilometers of desert, cliffs, valleys, and sandstone massifs. Unlike many deserts defined by dunes alone, Wadi Rum is a landscape of exposed rock, its history written vertically rather than buried beneath sand. At first glance, Wadi Rum appears, timeless, but every surface here is the result of long, precise processes that began hundreds of millions of years ago. The foundation of Wadi Rum is sandstone, rock formed from ancient sand deposited when this region lay near sea level. During the Cambrian and Ordovician periods, rivers and shallow seas spread sand across vast plains. Over time, these sediments compacted and cemented into thick sandstone layers, some of the oldest exposed rock in Jordan. Later, tectonic forces lifted the Arabian Plate, raising these layers high above sea level. Faulting and uplift fractured the rock, creating weaknesses that erosion would later exploit. As the land rose, water began carving downward. This is where Wadi Rum's shape truly began. Despite its modern aridity, Wadi Rum was once far wetter. Rainfall flowed through cracks and low points, carving channels, widening joints, and hollowing canyons. Flash floods rushed through narrow corridors, scouring rock walls smooth. Over millions of years, water removed vast amounts of material, leaving behind towering cliffs and isolated mountains. When the climate gradually dried, wind took over. Sand carried by desert winds acted like sandpaper, polishing exposed rock and deepening grooves. Softer layers eroded faster than harder ones, creating vertical faces, ledges, and freestanding pillars. Where fractures intersected, rock collapsed, forming arches and bridges. The result is a desert of architecture, forms that look designed but are entirely natural. One of Wadi Rum's defining features is its scale. Sandstone mountains rise abruptly from flat plains, creating dramatic contrast. Some cliffs exceed 1,700 meters in height. The open space between formations amplifies their presence. There's little vegetation to soften edges or hide structure. Light transforms the desert constantly. At sunrise, the rock glows deep red and orange. At midday, colors flatten into pale ochre and tan. At sunset, shadows stretch across the sand, and the cliffs darken into purple and brown. At night, the desert becomes nearly black, while the sky explodes with stars. The sand itself varies in color: red, pink, yellow, and white, depending on mineral content and grain size. Iron oxides deepen reds. Quartz-rich sands lighten surfaces. Wind redistributes grains constantly, reshaping dunes around stone. Wadi Rum is not static. It is always moving, slowly. But geology alone does not define this place. Human presence in Wadi Rum stretches back tens of thousands of years. Archaeological evidence shows Paleolithic hunters passed through the region, leaving behind stone tools and campsites. Later, Neolithic peoples carved symbols into rock faces, petroglyphs depicting animals, humans, and abstract shapes. These carvings still exist. Across Wadi Rum's cliffs and boulders, thousands of inscriptions record human movement and belief. Thamudic, Nabatean, Arabic, and other scripts appear side by side, etched into stone. Names, prayers, tribal marks, and messages remain legible centuries later. Wadi Rum functioned not as a settlement, but as a corridor. Caravans moved through it. Nomadic groups crossed it seasonally. Traders, shepherds, and pilgrims passed between the Arabian interior and the Levant. The desert remembers all of them. Water made this possible. Though Wadi Rum appears dry, water exists just below the surface. Natural springs, seeps, and rain-fed pools formed critical waypoints. Knowledge of these sources meant survival. Losing them meant death. This knowledge was preserved by the Bedouin. For centuries, Bedouin tribes lived in and around Wadi Rum, adapting to its extremes. They navigated by stars, landforms, and wind. They knew where water would collect after rain. They read the desert the way others read maps. To the Bedouin, Wadi Rum was not empty. It was alive with meaning. In the early 20th century, Wadi Rum entered global history through war. During the Arab Revolt against the Ottoman Empire in World War I, Wadi Rum served as a base and passage for Arab forces. The desert's remoteness provided cover. Its pathways allowed surprise movement. One of the most famous figures associated with this period was T.E. Lawrence, later known as Lawrence of Arabia. His presence, though brief, linked Wadi Rum to global narratives of rebellion and empire. Yet the desert itself remained unchanged. Empires passed, the rock stayed. In modern times, Wadi Rum gained international recognition for its visual power. Its landscapes have been used repeatedly in film to represent other worlds, Mars, distant planets, and mythic realms. Its cliffs and valleys appear alien not because they are unreal, but because they are stripped of excess. There is nothing here to distract from form. Scientifically, Wadi Rum is significant because it exposes geological layers clearly. The lack of vegetation and soil allows direct observation of stratification, faulting, and erosion patterns. It is a natural classroom for understanding desert geomorphology. It also shows how deserts preserve history. In wetter environments, vegetation, soil, and erosion erase traces quickly. In Wadi Rum, inscriptions carved into rock can survive for thousands of years. Footpaths remain faintly visible. Campsites leave subtle scars. Preservation comes from dryness, but this preservation is fragile. Tourism has increased dramatically in recent decades. Vehicles compress sand. Foot traffic damages rock art. Development threatens the balance between access and protection. In response, Wadi Rum was designated a UNESCO World Heritage Site in 2011, recognized for both its natural and cultural value. Protection efforts aim to preserve not just scenery, but silence. Sound behaves differently in Wadi Rum. With little vegetation and vast open space, noise travels far. Wind becomes audible. Footsteps echo. Silence feels expansive rather than empty. At night, the desert reveals another layer. With minimal light pollution, Wadi Rum offers some of the clearest night skies in the region. The Milky Way stretches across the horizon. Stars reflect faintly off pale sand. Meteor streaks appear unexpectedly. This sky mattered deeply to those who crossed the desert before modern navigation. Stars were guides, calendars, and stories. Wadi Rum connects ground and sky. The desert's extremes shape perception. Heat during the day can be intense. Cold at night arrives quickly. Shade is rare. Shelter matters. Movement must be deliberate. These conditions discourage permanence. No city rose here. No empire settled fully. Wadi Rum resisted ownership. This resistance is part of its power. It remains open, exposed, and unfinished. Even today, erosion continues. Arches thin, cliffs collapse, sand migrates. Nothing here is permanent, not even stone. And yet, the overall form remains recognizable across millennia. This paradox defines Wadi Rum. Change without erasure, memory without monuments, history without buildings. Standing among its cliffs, it becomes clear why Wadi Rum feels ancient even when untouched. It is not the age of the rock alone. It is the accumulation of passage, geological and human, layered without being overwritten. Wadi Rum does not overwhelm through density. It overwhelms through space. It gives nothing easily. It hides nothing completely. The desert does not explain itself. It simply exists, shaped by forces far larger than any one story. In southern Jordan, where redstone meets open sky, Wadi Rum remains a place where Earth's deep history and human memories share the same surface. A desert carved by water, polished by wind, marked by footsteps, remembered by stone. Wadi Rum is not empty. it is full of time. The rivers of fire that turn to stone. Beneath the quiet farms, forests, and coastal roads of Jeju Island lies a hidden world carved not by water, but by fire. Long tunnels stretch for kilometers underground, their walls frozen in motion. Ripples, drips, and waves of stone that record the moment molten rock stopped flowing. These are not ordinary caves. They are lava tubes, formed when rivers of lava drained away and left behind hollow arteries in the Earth's crust. Together, they make Jeju one of the most extensive and scientifically important lava tube systems on the planet. The lava tubes of Jeju are part of the Jeju Volcanic Island and Lava Tubes UNESCO World Heritage Site, recognized for preserving some of the finest examples of lava tube formation anywhere in the world. Among them, Manjangol Lava Tube stands out as one of the longest lava tubes known, but it is only one part of a much larger volcanic story. Jeju Island itself did not rise from tectonic collision like most of the Korean peninsula. It was built almost entirely by volcanic activity. Over hundreds of thousands of years, repeated eruptions poured lava across the land, stacking layer upon layer of basalt until the island emerged from the sea. The lava tubes formed during this long period of eruption. To understand how, it is necessary to imagine lava not as an explosion, but as movement. When basaltic lava erupts, it is relatively fluid compared to other types of magma. It flows easily, spreading across the landscape in rivers rather than erupting violently. As lava moves, its surface cools quickly when exposed to air, forming a hardened crust. Beneath this crust, lava continues to flow, insulated from cooling. Over time, these flowing rivers become enclosed. If the eruption continues long enough, a stable tunnel forms, its roof solidifying while molten lava keeps moving beneath. When the eruption eventually slows or stops, gravity drains the remaining lava downslope, leaving behind an empty tube. What remains is a perfect record of motion. The walls of Jeju's lava tubes preserve flow lines, curving ridges that show the direction and speed of lava movement. In some places, lava drips froze mid-fall, forming stalactite-like shapes made of basalt rather than limestone. Floors display lava benches, shelves left behind as lava levels dropped in stages. These features make lava tubes fundamentally different from water-carved caves. They are not shaped by removal, but by absence, spaces left behind when fire moved on. Among Jeju's lava tubes, Manjangol Lava Tube is the most famous. Stretching over 7.4 kilometers, it is one of the longest lava tubes ever discovered. Parts of it reach heights of over 20 meters, wide enough to hold buildings inside. Manjangol is notable not just for size, but for preservation. The tube contains some of the largest known lava columns in the world, formed when lava pooled and drained repeatedly, leaving behind thick pillars of solid basalt. One such column stands over 7.6 meters tall. Lava rafts, flat slabs that once floated on molten rock, are frozen into the floor. The ceiling shows collapsed sections where the roof failed, allowing light and air to enter. These skylights created microenvironments where plants and animals could later colonize. But Manjangol is only one part of a system. Jeju contains dozens of major lava tubes and hundreds of smaller ones, many still unexplored or closed for protection. Together, they form a network beneath the island, tracing the paths lava once took from eruption vents to the sea. The source of this activity is Halasan, Jeju's central volcano. Though Halasan is now dormant, it was once highly active, producing extensive lava flows. As eruption shifted over time, new tubes formed while older ones were abandoned. This repeated cycle created layers of underground voids at different depths. Scientifically, Jeju's lava tubes are exceptional because of their diversity. Different eruption phases produce tubes with varying shapes, sizes, and internal features. Some are narrow and smooth, indicating fast, steady flow. Others are wide and irregular, showing fluctuating lava levels. These variations allow volcanologists to reconstruct eruption behavior in detail. Jeju's climate adds another layer of significance. Unlike lava tubes in dry regions, Jeju's are located in a humid, temperate environment. Over time, water seeped into the tubes, introducing secondary processes. Minerals precipitated on basalt walls. Thin calcite formations appeared in places, creating rare hybrid features where volcanic and karst-like processes overlap. This makes Jeju's lava tubes unique globally. Life also found a way inside. Despite total darkness and stable temperatures, the lava tubes host specialized ecosystems. Bats roost in some sections, using the caves for shelter and hibernation. Insects and microorganisms adapted to low light thrive in niches where moisture collects. Some species found in Jeju's lava tubes exist nowhere else. The caves also played a role in human history. For centuries, people living on Jeju used lava tubes as shelters, storage spaces, and places of refuge. During periods of conflict, some tubes were used to hide entire communities. Their stable temperatures made them valuable for food storage, protecting crops from heat and cold. This relationship between humans and lava tubes continued into the modern era. During the mid-20th century, particularly during the Jeju Uprising, caves were used as hiding places and defensive positions. These events left marks not just on the landscape, but on collective memory. The lava tubes, once formed by fire, became places of survival. In recognition of their geological and cultural importance, Jeju Volcanic Island and lava tubes were designated a UNESCO World Heritage Site. In 2007, protection efforts focus on preserving both visible sections like Manjungle and hidden systems, vulnerable to development. Preservation is critical. Lava tubes are structurally fragile. Roof collapses can occur naturally, but human vibration, construction, and uncontrolled tourism increase risk. Changes in groundwater flow can damage delicate internal features. For this reason, only limited sections are open to the public. Inside Manjungle, visitors walk along a defined path. Lighting is carefully controlled to prevent algae growth. Temperatures remain cool year-round, hovering around 11 to 21 degrees Celsius, regardless of surface weather. The experience is immersive. Sound is muted. Light falls unevenly across black stone. Walls curve smoothly, revealing the flow of ancient lava. There's no sense of water shaping space, only motion stopped mid-gesture. Geologically, Jeju's lava tubes offer insight into planetary processes beyond Earth. Similar lava tubes are believed to exist on the Moon and Mars. On those worlds, tubes could provide natural shelter from radiation, temperature extremes, and meteor impacts. Studying Jeju's tubes helps scientists understand how such structures form and persist. In this way, Jeju's underground landscape contributes to space science as much as Earth science. Above ground, Jeju Island appears calm. Fields, villages, and forests cover the surface. The violent past that formed the island is not immediately visible. Below ground, it is unmistakable. The lava tubes are arteries of creation, pathways through which the island was built. They show that land does not always rise through sudden catastrophe. Sometimes it forms through repeated, steady flow. Each tube represents an eruption. Each eruption represents change. Each change left a trace. The tubes also remind us that landscapes are layered not just in rock, but in function. What was once molten became shelter. What was once destructive became protective. Jeju's lava tubes do not advertise themselves from the surface. They require entry. They require descent. And once inside, they reveal a story written in stone that is rarely visible anywhere else. A story of fire that moved like water, of ground that emptied itself, of space created by departure rather than destruction. Beneath Jeju Island, the rivers of lava still exist, not as heat, not as danger, but as form. Frozen pathways, silent tunnels, records of a time when the earth flowed freely beneath the sky. The lava tubes of Jeju are not caves carved by erosion. They are memories of motion, preserved underground, waiting quietly beneath an island built by fire. The stone forest left by a vanished sea. In the coastal desert of Western Australia, where sand dunes stretch toward the Indian Ocean and wind moves freely across open ground, thousands of limestone spires rise abruptly from the earth. Some are short and rounded, others tall and needle-like. A few resemble columns, others broken teeth or twisted figures. They appear randomly scattered, yet unmistakably deliberate, as if placed rather than formed. This is the Pinnacles, one of Australia's most unusual and debated geological landscapes. The Pinnacles are located within Nambung National Park, roughly 200 kilometers north of Perth. Despite their stark, almost alien appearance, the Pinnacles are not the product of volcanic activity, erosion by wind alone, or human intervention. They are the exposed remains of an ancient seabed, stone shaped by water, chemistry, burial, and time. To understand the Pinnacles, it is necessary to imagine a very different Australia, around 25,000 to 30,000 years ago, during the late Pleistocene, global sea levels were significantly lower than they are today. Large volumes of water were locked in ice sheets, and coastlines extended far beyond their current positions. The area that is now Nambung National Park lay beneath shallow marine waters. These waters were rich in calcium carbonate, derived from shells, coral fragments, and marine organisms. Over time, sediments accumulated on the seabed, compacting into limestone. This limestone was not hard rock at first. It was porous, soft, and chemically active. As climates shifted and sea levels rose and fell, the limestone experienced cycles of wetting and drying. Rainwater, slightly acidic from dissolved carbon dioxide, seeped into the rock, dissolving calcium carbonate and redepositing it elsewhere. This process, known as karstification, created internal cementation in some areas while weakening others. The result was uneven strength within the limestone. Some portions hardened into resistant columns. Others remained soft and eroded easily. Later, as the sea retreated permanently from the area, wind-driven sand dunes swept across the landscape. For thousands of years, the limestone formations were buried beneath layers of sand, hidden completely from view. This burial is critical. While underground, the limestone continued to harden. Groundwater moved through the sand and rock, depositing more calcium carbonate within fractures and pores. The buried columns became stronger, while surrounding material remained comparatively weak. Then, erosion returned. As wind stripped sand away and dunes migrated, the buried limestone was slowly re-exposed. The softer surrounding limestone eroded first, leaving behind the hardened cores, stone pillars standing alone in the sand. These are the pinnacles. They were not carved into shape. They were revealed. This process explains why the pinnacles vary so widely in size and form. Each spire reflects the internal structure of the limestone it came from. Differences in cementation, composition, and fracture patterns amplified by erosion. Some pinnacles retain fossil impressions. Close inspection reveals shell fragments embedded in stone, direct evidence of their marine origin. Others show layering, revealing how sediment accumulated over time. The sand surrounding the pinnacles is not uniform either. It shifts constantly with wind and season, sometimes burying lower portions of the spires, sometimes exposing new bases. This movement gives the landscape a sense of motion, even though the stone itself is static. From a distance, the pinnacles appear frozen. Up close, they feel temporary. Light plays a major role in shaping perception here. At sunrise, long shadows stretch across the desert floor, emphasizing height and isolation. At midday, harsh light flattens forms, making the spires appear bleached and stark. At sunset, the limestone glows warm golden orange, contrasting with the pale sand and deepening sky. At night, the pinnacles take on another identity entirely. Under starlight, they become silhouettes, black shapes against a luminous sky. With minimal light pollution, the Milky Way arcs overhead, turning the desert into a meeting point between Earth and sky. The pinnacles are often described as mysterious because, for decades, scientists debated how they formed. Early theories suggested they were remnants of ancient trees whose roots had mineralized. Others proposed they were shaped primarily by wind erosion. Some thought they were the result of ancient termite mounds that hardened into stone. None of these explanations fully matched the evidence. Modern geological study supports the marine limestone origin combined with differential cementation and erosion. Yet even now, details are refined continuously. The pinnacles are not fully solved. They are understood well enough to explain their existence, but not so precisely that every variation can be predicted. This uncertainty contributes to their enduring intrigue. Human interaction with the pinnacles is relatively recent. Indigenous peoples lived in and moved through this region for tens of thousands of years. While there is limited direct evidence linking cultural practices specifically to the pinnacles, the land itself forms part of a broader indigenous landscape rich with meaning, navigation knowledge, and seasonal use. The stone formations were not isolated wonders. They existed within a living system of dunes, water sources, and travel routes. European awareness of the pinnacles developed in the 20th century as coastal exploration and road access increased. Early visitors described the formations as eerie, unnatural, and almost unsettling. In 1967, the area was designated Nambung National Park, granting protection to the formations and surrounding desert. Today, the pinnacles are one of Western Australia's most visited natural landmarks. Despite their popularity, the environment remains fragile. The limestone spires are brittle. Touching, climbing, or removing fragments accelerates damage. Foot traffic can compact sand, altering erosion patterns. Preservation depends on restraint. From a scientific perspective, the pinnacles offer insight into how landscapes can be shaped as much by burial as by exposure. We often think erosion creates features by removing material. Here, erosion revealed features by removing what hid them. The pinnacles also demonstrate how coastal environments shift dramatically over geological time. What is now arid desert was once seabed. What is now inland was once shoreline. This reminds us that coastlines are not permanent. Climate cycles continue to reshape them. The pinnacles are also valuable for understanding karst processes in non-tropical environments. Unlike classic karst landscapes dominated by caves and sinkholes, the pinnacles represent a surface expression, columns left behind rather than voids created. They are, in a sense, the inverse of caves. Where caves are spaces left behind by dissolved rock, the pinnacles are the rock left behind after everything else dissolved. Visually, this reversal feels uncanny. The desert appears populated, almost crowded, despite being empty of life. The spires suggest presence without inhabitants, structures without builders. This contributes to the sense that the pinnacles resemble ruins, even though they were never constructed. They are not the remains of a city. They are the remains of a sea. Standing among the pinnacles, it becomes difficult to judge scale. Without trees or buildings for reference, the mind struggles to orient. The formations feel closer or farther than they are. The desert floor dips subtly, altering perspective with every step. Sound behaves strangely here. Wind moves freely, but stone absorbs echo. Footsteps feel loud. Silence feels deliberate. The pinnacles do not invite long stays. There is little shade. Heat builds quickly. Exposure is constant. The environment discourages comfort. This discomfort may be part of why the landscape feels so striking. It's not softened for humans. It does not adapt. The pinnacles are indifferent. Over time, they will change. Wind will continue to erode exposed edges. Sand will bury some spires completely. Others will collapse as their bases weaken. New forms may emerge as deeper limestone is uncovered. Eventually, the field may disappear entirely. This impermanence contrasts sharply with the impression of age and solidity the pinnacles convey. They look ancient, and they are, but they are also temporary, existing in a narrow window between burial and collapse. That window happens to coincide with human observation. In Western Australia, beneath vast sky and shifting sand, the pinnacles stand not as monuments to permanence, but as reminders of transition. They mark a moment when the sea retreated, the sand moved on, and stone was left standing, exposed, isolated, and vulnerable. Ar-at-ach, forest without trees, a city without people, a shoreline without water. The pinnacles do not tell a single story. They tell many layered ones, of oceans that vanished, dunes that wandered, chemistry that hardened stone, and erosion that chose what would remain. They stand because everything around them did not, and in that absence they endure, quiet, pale, and unmistakable, waiting for the desert to decide what comes next. As this journey comes to an end, these places remain, quiet on the surface, yet shaped by powerful forces still at work beneath them. They remind us that the earth is never finished, only changing in ways we're just beginning to understand. Thank you for watching Unearthed Secrets. Until next time, keep looking closer at the world beneath your feet.